Sound Reinforcement System Design for Aspiring Engineers. Hello, I am Sarah from Sangelsoft. Welcome to our course. In this session, we will look into the following topics: sound reinforcement systems, components of a sound system, sound reinforcement standards, audio distribution protocols, sound reinforcement system design, acoustic simulations. Today, we're diving into the world of sound reinforcement, what it is, why it's essential, and how you can master it as an engineer. First things first, what is sound reinforcement? Simply put, it's the process of amplifying sound to ensure it can be heard clearly in larger spaces. Whether you're at a concert, a conference, or even a theater performance, sound reinforcement plays a crucial role in delivering the audio experience. Now let's talk equipment. A typical sound reinforcement system includes microphones, mixers, amplifiers, and loudspeakers. Each piece works together to capture, manipulate, and project sound. Let's break these down. Microphones. These capture sound from sources like singers or instruments, converting sound waves into electrical signals. Selecting the right microphones is crucial. We have dynamic mics, condenser mics, and ribbon mics, all suited for different situations. For example, dynamic mics are perfect for live vocals due to their durability and feedback rejection. Mixers. Mixing consoles allow us to adjust levels, add effects, and route sound to different outputs. Mixing is where the magic happens. Balancing the levels, adding effects, and EQing sounds can either make or break a performance. Your goal is to create a blend that sounds natural and engaging. Always trust your ears and make adjustments based on the venue. Amplifiers. These boost the audio signals from the mixer, ensuring that the sound is powerful enough to fill a venue. Loudspeakers. Finally, loudspeakers convert electrical signals back into sound waves, delivering the audio to the audience. Understanding how to set it up and where to position the speakers can drastically change the audio quality. Placement is key. Angle the speakers towards your audience and avoid placing them near walls to minimize echo and reflections. Sound reinforcement standards. Some of the widely recognized audio standards are BS 6259-2015, Code of Practice for the Design, Planning, Installation, Testing, and Maintenance of Sound Systems. BS EN IEC 60268-16, 2020, Sound System Equipment. Part 16, Objective Rating of Speech Intelligibility by Speech Transmission Index. AVIXA, ANSI, Infocom, A102.01, 2017, Audio Coverage Uniformity in Listener Areas. AVIXA, ANSI, Infocom 10, 2013, Audiovisual Systems Performance Verification. Audio Distribution Protocols. For low-latency, real-time audio distribution for sound reinforcement applications, there are many proprietary and open protocols. Some of the widely used audio distribution protocols in digital AV systems are RockNet, CobraNet, AES67, and Dante. RockNet. RockNet is a real-time, low-latency latency audio distribution network protocol tailored to live and installed sound applications developed by Ridel Communication. It conveys up to 160 channels of 24-bit, 48 kHz audio counter rotating on a single Cat6 cable, even though RockNet is not an Ethernet or Layer 2-based protocol CobraNet. CobraNet is considered by most to be the first real audio over Ethernet, a Layer 2 solution, allowing multiple channels of audio to be transferred bidirectionally over a single Cat5e network cable to any number of locations, thus eliminating the need for point-to-point audio connectivity. CobraNet is developed by Peak Audio, AES67. AES67 is an open protocol for audio over IP and audio over Ethernet, AoE, interoperability. The standard was developed by the Audio Engineering Society. It is a Layer 3 protocol suite based on existing standards and is designed to allow interoperability between various IP-based audio networking. Dante. Dante is a proprietary network Layer 3 audio transportation protocol developed by Audinate. Dante packages audio data as a payload inside an UDP IP packet. That means Dante traffic is fully routable. A router can send it from one LAN to another or from inside a VLAN to outside a VLAN. Acoustic simulation refers to using computer software to predict how sound behaves in a given environment. It allows engineers to visualize sound propagation, analyze sound pressure levels, and optimize designs before any physical testing or implementation. Not only does this save time and resources, but it also enhances creativity and innovation in design processes. Software tools like ANSYS, COMSOL, and EASE are essential for virtual testing. In this lesson, we are using EASE, Enhanced Acoustic Simulator for Engineers for acoustic simulations. Whether you're interested in designing quiet spaces, creating immersive sound experiences, or ensuring product compliance, understanding acoustics is vital. Acoustic simulation and testing are indispensable skills in various engineering disciplines. By mastering these techniques, you can contribute to creating spaces and products that enhance the auditory experience for everyone. Cinema sound system. Dolby and THX Limited was established in 1983 by Tomlinson Holman and the George Lucas Company with the purpose to create standards to correct inadequate movie playback in cinemas. THX is an acronym for Tomlinson Holman Experience. In 1998, the Dolby Digital Surround EX was introduced, a joint venture between Dolby and Lucasfilm THX, to give movie producers the ability to differentiate between left, right, and rear surround signals. Speaker arrangement of a Dolby Digital Surround EX is shown here as an example for the cinema sound system. The front loudspeaker systems, 3-way, 4-way, or 5-way systems, full range inclusive low bass, are normally installed in a sound baffle behind the perforated movie screen. This sound baffle is also a part of the THX recommendations. The front loudspeaker channels should be installed in a height of about 2 by 3 of the cinema screen and should be angled to the ear height of the seats in about 2 by 3 of the audience area. All movies should be presented at these above-mentioned standard fader settings with a SPL of 85 dB C-weighted. Sometimes loud trailers may need compensation downwards, but normally standard level should be executed all time. But often this is felt as too loud, and in many theaters the standard fader level is set to 79 dB C-weighted, minus 6 dB down from the recommendations to create a more comforting listening level. However, for design considerations, the maximum sound pressure level that could be output of the sound system, each individual speaker, should be equal or greater than 105 dB without amplifiers overloading or clipping. LFE, low-frequency effects. A separate low-frequency channel was introduced to reproduce special low-frequency content. This LFE channel has normally a bandwidth of 20 Hz up to 120 Hz and set at 10 dB lower than surround channels. It should not be used for the entire low-frequency content of the multi-channel sound presentation. The left and right channel are equipped with their own independent subwoofer systems. The LFE channel should only carry the additional low-frequency enhancement information or effects, such as explosions. The surround speaker channels are set individually to minus 3 dB compared to the master channels because the acoustical sum of both surround channels adds up to 0 dB if the content is equal. Surround speakers must provide uniform coverage of all audience. Here the spacing between speakers, height above floor, and aiming angle are important. The sidewalls should not be reflective to avoid any kind of flutter or side slap echoes. The walls must be acoustically treated with absorptive material down to a height below ear height of the seated audience. For acoustic simulation, EASE Enhanced Acoustic Simulation for Engineers, which is an industry standard software for acoustical studies, is used. This stadium is having 16 numbers of 15 cabinets. Line arrays are used for the following acoustical simulations: direct SPL, total SPL, C8 clarity, STI speech transmission index, direct SPL. The direct sound pressure level measures the sound energy arriving from the loudspeakers on a direct line of sight path at the receiver. For each loudspeaker, the received level is determined based on the distance of the loudspeaker, its direction, the electrical power supplied to the loudspeaker, and the properties of air. The contributions of all loudspeakers are summed at the receiver location. Total SPL. The total sound pressure level represents the sum of the direct sound energy and the reverberant energy. For standard mapping, the reverberant energy is calculated based on the airing reverberation time and the overall power radiated by the active loudspeakers. C80. The clarity 80 describes the temporal transparency of musical performances. It corresponds to the ratio of energy before and after a cutoff time of 80 milliseconds. The clarity measures represent the ratio of early energy to late energy expressed in dB. The cutoff time separating early from late energy can be 7 or 50 or 80 milliseconds. This parameter is used to predict the articulation of different modes of music. This articulation is dependent upon the speed of the music, the type of instrument, and the reverberation of the room. As an example, 6 plus 2 dB is ideal for percussive instruments. This can be described best as rock and roll. STA. The Speech Transmission Index, STI, is a measure for speech intelligibility and is computed according to IEC 60268-16. For full standard compliance, the input signal should be set to the speech spectrum as defined by the standard. Signal and noise masking should be switched on as well. STI values can be roughly qualified as follows: 0.75 excellent, 0.60 to 0.75 good, 4.5 to 0.60 fair, 0.3 to 4.5 poor, 0.3 bad. Fair value 0.55. STI shall be achieved to comply with NFPA or FIFA standard. The future of sound reinforcement techniques is exciting and holds great promise for immersive audio experiences. Let's explore some key developments. Immersive audio with vision intelligence. Analog devices envisions a future where audio systems leverage vision intelligence to create novel sound reproduction techniques. These systems will be developed with an improved understanding of how our minds process and localize sounds. Cutting-edge time-of-flight, imagers, and powerful DSPs will enable 360-degree immersive sound experiences without requiring a large number of speakers. Deep reinforcement learning, DRL. DRL has made progress in the audio domain, impacting speech and music-related applications. Researchers are exploring how DRL can enhance sound processing, localization, and adaptive audio systems. Room enhancement features. Combining advanced sound reinforcement techniques with room enhancement features opens up new possibilities for concerts, shows, and acoustic environment design. These features improve sound quality, spatial perception, and overall immersion. Remember, sound is an art. It's about creating experiences and connecting with people through audio. Whether you dream of working in live events, studios, or even film, mastering sound reinforcement will set you on the right path. Thank you for watching. Stay tuned, keep listening, and remember, in sound, every detail matters. Exciting times ahead. See you next time.